Hey everyone, it's Benny here, and in this video, we are back to talking about this Minecraft computer that we built so long ago. And the reason we're going back to this is because, although I made the tutorial series on how you can build this, I never showed you how you could use it to do something that's actually useful. So that's what I'm going to be doing in this video and in this series, because I'm going to be making a series of a whole bunch of different things you can program this Minecraft computer to do that I personally think are kind of neat things to do with Minecraft computer. So, with that out of the way, let's go ahead and get started with the first thing that I'm going to show you how to program it to do, which is how to password lock any Redstone machine you can imagine using this Minecraft computer, which is actually a lot simpler than it sounds. So, let's get started. First off, I have two input panels. User input 1. This is the password. You input the password here. And we also have user input 2. This is a control panel. This is what we use to control whatever Redstone machine we have it hooked up to. And we can hook it up to absolutely anything we want. So, the way this is going to work is if I input the password correctly, then the control panel will have whatever I input here sent to the Redstone machine, which in this case is just a binary output. So I have a sort of a boring Redstone machine. It's just going to display whatever I put into the input panel. But you could hook this up to anything you want. You could hook up to a door, you could hook it up to an elevator, you could hook it up to a bridge, you could hook it up to a cobblestone generator, you could hook it up to any Redstone machine you want. I just have it as an input panel, just for sake of easily knowing that the password system's working. That's what it's about. It's not about the machine it's hooked up to, it's about the password system. So let's go ahead and get started. First off, I'm going to have to load the program, and I'm just going to put in a password I know is wrong. I'm going to put in 12, which is not the password. So I'm going to turn it on, and if I get the password wrong, this light's going to turn on. So I'm just waiting for it to process that, and the light turns on. That means the password's wrong. And right now I do have it programmed just to turn on the light if the password's wrong, but you can program it to do anything you want if the password's wrong. If you wanted, you could program it to drop you into a lava pit if the password's wrong. Again, you can use your imaginations. I'm just making it do the simplest things possible for sake of demonstration. So there we go. That's what happens if the password's wrong. And the password I actually have it set up to is 5. And if I get the password wrong, then it does not let me put the right password in. So you notice I have the right password in now. And now if I start inputting things, it's not letting me go through. So I have to get the password right the first time. I can't just get it warmed up and then keep trying passwords till I get it right. I have to get the right password. So I'm going to unload the program. That should turn the light off. And I'm going to turn the computer off. So I'm going to load the program again, this time with the correct password in. I'm going to turn the computer on. So it should be doing the processing to figure out if I have the password incorrectly. I'm just going to turn every single one of the input things on. And you should notice all the binary outputs are showing what I have this in, so the password's been accepted. And I can undo the password now and it's still going to give me access to it. It just needs the initial check. So in theory I could set it up to use this input system afterwards if I needed extra input for some reason. But for now, I'm just using this panel. And yeah. So, again, if I want to not have access to it anymore, just unload the program, and I lose access to it until I put the password in again. So there we go, that's how it works. It's actually pretty simple in the end. Just put in the correct password and you can use it. And if you put the password in wrong, it doesn't let you use it. And it's fail-safe checking, so you can't put the password in or guess and check until you get the password right. If you get it wrong, you get it wrong. Until the computer is reset. So yeah, there you go. That's the demonstration of this. And now we're going to go over how you can program the computer to do this. Alright, we're back. So I went ahead and completely erased the program from the computer off camera. So if I go ahead and load the program and run it now, it's going to do absolutely nothing whatsoever. And yeah. So now I'm going to show you how you can program this computer to do this. Now there's a couple of prerequisites if you want to follow along. First off, you're going to need to have built the computer, and you will also need to have installed both the conditional branching system and mathematical branching, and you'll need to have enabled mathematical branching. So yeah. And if you don't want to go through my series and follow all that and build it all on your own, then I will be providing the download for the world as is in the description for you to enjoy and do whatever you want with. So let's start programming this computer. So first thing we're going to do is we're going to talk about how we're going to solve the password problem. And because obviously if we're going to program the computer to do anything, we need to know how are we going to get it to accept the password. Well, here's the way I'm going to have it set up. I'm going to have the password programmed into the read-only memory. I have it programmed into read-only memory number 1 right here. And this is how it's going to work. We're just going to have the password programmed in there. That's where the computer's going to get the information from. So it'll take that information, and the way we're going to determine if it's the correct password or not is we're going to take the correct password from memory and the password that the user gave us, and we're going to subtract them. And the reason we're going to do that is because of the way conditional branching works. It only branches if it's 0. If we subtract the password and it's correct, in theory they should be equal. And if they're equal, then 2 of the same number subtracted will equal 0. So that'll make us branch. So that's the way we're going to make it work. And of course, if we branch, we're going to go into the case of we control the whatever Redstone machine it is. And if we don't branch, we're going to go to the case of, hey, the password's wrong. So the very first thing we're going to need to do is we're going to need to load the password from the read-only memory over here, and we're going to need to load it into our arithmetic logic unit for processing. So let's do that. And sorry, my recorder cut off. So let's do that. So you notice we have all of our commands nicely labeled. We're going to want to read the read-only memory. So you notice we have a nice command here called read-only memory. So we're going to want to do that. And now we're going to need to select it. Now, the way the computer has internally labeled read-only memory is that user input panel 1 is 0, the user input 2 is 1, 2, and free. So read-only memory 1 is actually free in terms of the way the computer has it set up. So I'm going to go into the computer, and I'm going to select bit the number. I can select both bits because that would be free in binary, because 1 plus 2 is free, of course. So there we go. We now, if we run this, and in fact I will using the debugging system. So there we go. We should have the correct password on the reading bus, and hey, we do. Cool. Doesn't help us that much though, but we're making progress. So next thing we need to do is we need to take whatever's on the reading bus, and we need to send that information to the arithmetic logic unit, because if we're going to need to do subtraction, all is done in the ALU, we need to send it to the ALU. So we have this thing right here that says send the RAM, which is and RAM in this case is actually whatever's on the reading bus, so send whatever's on the reading bus to the ALU. So there we go, that'll send it to the ALU. But it doesn't save it to the ALU, it just gives the information to the ALU. The ALU doesn't do anything with it yet. We want the ALU to do something with it. In this case, we want it to be input A. And it could be really either one in this case, but I'm just going to put it as input A. And that should be just about everything we need to do in this command. So if I run this first line of code right now, should load the password onto the bus, should send it to the ALU, and the ALU should save that as the first input. So I'm going to just use the debugging system to run that line of code, and it's already done because it's pretty fast. And you'll notice it has the password saved into it. And it also has some other information saved in there because I had never actually cleared the ALU inputs. But that's okay. It saved it in there, and that's what matters. So we actually will need to go back later and determine the next commands it needs to go to and command ordering and stuff, but I'm just going to leave that out for now. We can go back and do that later. I'm just worried about the actual logic of the program working. So now that next thing, we're going to need to do pretty much the same thing except for the password input, and we're going to want it as input B. So I'm going to do almost exactly the same thing on the second line of code. I'm going to go to the read-only memory section, going to read it, and this one's going to be 0 in the way the computer has it labeled, so I'm not going to need anything else. And I'm going to want to send that to the ALU, and I'm going to want it to be input B this time. So now if I put in a password, I'm just going to put in, 7 because, I don't know, just picking a number. And if I run this command, it should have that number on the bus, so it should be reading the number. It is, it's on the reading bus. It should be sending it to the ALU, and I'm noticing information coming through here, so it is indeed going to the ALU, and the ALU should be saving it. So if I turn off this command, then the ALU should have 7 saved to it. And if I look, you might not be good at reading the ALU input, but take my word for it, this does have 7 as the input. So, there we go. We've got at least the first part of the second command working. Now, there's really no point going to the third command to do the rest of this, so I'm just going to go ahead and do everything here. We're going to need to subtract them. So here's the ALU commands, we subtract. So there we go, we are subtracting them. And other than that, the rest will be done in conditional branching. So the way I'm going to do it is, I'm just going to have the rest of the program written from here on out. So the next command will be here, and the next command here, and yada yada yada. And if they get the password wrong, it's going to kick them all the way over here. We'll have whatever we want to do with the, if they get the password wrong, done on this line of code. So, now we're going to have to handle, what if they get the password right? What do we want them to do? Well, first we're obviously going to need to read the user input here. So we're going to need to read that to the bus, and then we're going to need to send it to the Redstone machine. And it can be in either expansion slot 1 or expansion slot 2. In this case, it's my binary output, which I have hooked up to expansion slot 1. So that's what I'm going to do. And actually just a second, sorry about that. So now let's go, and we're going to hook it up to expansion slot 1. So again, same thing, go to reading read-only memory, except this time we're going to want number 1. So I'm going to select bit 1, that'll select ROM1, which was the user input. And now we're just going to need to send that to the Redstone machine. And that's at expansion slot 1. Now where are the expansion slots? They're actually sort of hidden behind a wire here, but you notice here's command for send to expansion slot 1. And there we go. So now, if I run this command, now, if this command's running properly, anything I input into this panel should be going into the expansion slot. And what do you know? It is. So there we go, we've got that command working properly. Now we have to handle the case of what if they get the password wrong. In this case, all I'm having to do is just turn the lamp on, which is the general indicator. So I'm going to follow that line all the way to the end. Just place a torch there. So there we go. Now if we get the password wrong, then it's just going to hook it up to the general indicator. And if you want, you can have a second Redstone machine that does something evil, so you could just... And the way you do that is just send it to expansion slot 2, and you'd build whatever redstone machine you want to do the evil thing if they get the password wrong there. So, yeah. Or you could hook it up to a completely different machine that for some reason. And, I think that should be just about all of the commands set up, except for the go-to thing, because that's really the hard part. So here's the way I like to set up the go-to system. I'm going to clear the ALU register, or not, I'm sorry, I have this labeled for a future program that I can show you how to do. So in that future program, I will clear the ALU registers, but in this program, this is all we care about. So these 8 commands will control both the branched command and the command that it will by default go to. So in this case, I want it to be both the same. That should be command 1, because it starts command 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yeah. And I want in any case, I want it to go to command 1. So if I go over here real quick, and I do manual branch, it should still be command 1. And it is. And actually, I'll need to disable mathematical branching for that, because it's always doing it, but yeah. In this case, always command 1. That's good, that's what we want. But next one is going to be a little bit different, because we're going to want to branch. We're going to want to go to the very last command if it branches, and if it doesn't branch, then we want to just go to the next command. So the next command would be command number 2. So in binary, that's just 1, 0. So it should be, I think it would be this one. Okay, yes. And this one would be the branched one. So that's that one, and I'm just going to go over here really quick and set this up again. Or whatever, let's just do a default branch. And there we go. So I've done an override branch. And now which ones am I going to want? I'm going to want this to be true, not that one to be true. So this one, now it should be just skipping every other one. So I'm getting the very last one. So there we go, that's going to the very last command, number 15. And if I go back and undo the branch, it should still be going to command 2. So good, there we go, that's what we want. Now this one, we want to just maintain access in this case, no matter what. Because, I mean, we're giving them access to the Redstone machines command. We don't want to go anywhere else from this. We just want to keep giving them access to the machine until the computer's turned off. That's the way I have it set up. So the way we're going to do this is we're just going to say go to this command, which is command 2. We're just going to say go to itself. That way the next command will always be this one, and it'll just essentially stay at this command. So this is going to be command 2, which I believe will just be both of these. And yeah, so that'll be the same in every case. And now the very last one, I'm also going to set it to be going to this staying at this command, because I just want the lamp to stay on indefinitely. Don't want to do anything else. So it'll just be torches all the way across. So we'll go to command 15, whether it's branching or not. And again, I have the 2 torches on this one, because that way it's 2 if it's branching and 2 if it's not branching. So there we go. That should, if I did everything correctly, that should be the final and working password program that I demonstrated in the first one. So let's go ahead and test. So to test, right now I have input 7, my programmed password is 5, and of course if I want a new password I could just easily reprogram this. So my current input is 7, I'm going to load the program and turn the computer on. And I should get the light on because I have the password in wrong. And it's processing, it's Still processing. So I think it's safe to say we did something wrong, because it has actually allowed me access even though I put the password in wrong. So okay, we know that's not working correctly. So let's unload the program and turn off the computer. So now let's put in the correct password and see what happens. So let's load the program and turn on the computer. And this time it should give us access if it's working correctly. But it has. So we clearly have done something a little bit wrong, because we are always getting access to to this. It's not branching properly. And that's bad, because if it's not branching properly, then it's clearly not, well, it's not useful, doesn't do it right. So let's do some debugging. Welcome to the world of debugging. It's going to be a lot of fun. So I'm just going to go back to the case where it shouldn't work, because it is going correctly for that, so I'm going to assume that that's working correctly. I'm just going to assume that somehow not branching in this case. That's what I'm assuming is a problem. So I'm going to turn off the computer. I'm going to unload the program and turn off the computer. So what I am going to do is I'm just going to run the program more or less manually and make sure every command is doing what it's supposed to. So command 1. First off, it should be reading from there, like I said. It should be reading the correct password and saving it to the AOU. This is indeed reading the correct password. It is being sent to the AOU, and the AOU is saving it. So that is working. That's okay. And I'm going to turn off rain again. So there we go. We know that part's working. Congratulations, we have command 1 working. So command 2 has to be where we screwed up, because this is the only command left before the branch. So this should be reading this, and it is. Sending it through, which it is. Should be saving it into the AOU. It is. As a different input, that's important. And it should be doing the math. And it is found it's not right. So it should say don't branch. And from the best I can tell, this is saying, yeah, don't branch, because this is an on, so it's not branching. So that's good. So if I go over here, it says when we don't branch, the next command is free. That's a bit of a problem. If we don't branch, the next command should not be free. It should be 15. So I'm just gonna break these torches, because we did this wrong. So now the next command is command 15. And there we go. So I'm going to turn this command off, and I'm going to turn that into the correct password. And now I'm going to simulate running it again so that I get the other one correctly, because I completely erased it. Right now we'll be going to command 0 if I got it right. That's clearly not what I want. So that should be loading it and saving it to the OU. It's done that. Now this should also be loading and saving the other one to the OU. And it should determine, which it did, that we branch. Now where do we want to go if we branch? Well, I want to go to command 2, not 1. 2. And there we go. Now it should go to command 2 if we branch. So there we go. That's working. We've successfully debugged our program, and let's try it again. So I'm going to input the incorrect password, going to load the program, and I'm going to start. So this time we should get general indicator if it branches, and oh look, it went to command 15, and we get the light on because it's not right. So there we go. We have done that wrong. I'm going to unload the program and turn off the computer. Now I'm actually going to do this a little bit differently just to show you that the password is truly easily programmable. I'm just going to change the password to what I have my input as, and now I'm going to run it again. So I'm going to load the program, and I'm actually going to turn all these inputs on to make it pretty obvious when we get access to the control panel, and turn it on. So now it's processing, seeing if we have put in the correct password, which we have, in theory. And then it gives us access to the control panel, just like I demonstrated earlier. It does automatic updating, and we can undo it, and it still doesn't let us, it still gives us access until we unload the program. So there we go. That was how to program the computer to do a password-locked thing. I know this was a somewhat long tutorial, but that's because I wanted to go a little bit in-depth on how everything works when you're programming the computer, because, it's a low-level programming. It's not the most intuitive thing to do at first. But there you go. That's how you can program a computer to do a password-locked door. So hope you understood, hope you enjoyed, and if you have anything at all that you think would be something interesting to know how to program the computer to do, that it can reasonably do. Obviously, I can't program this to run Minecraft because, for a couple of reasons, starting with I don't really have a graphical display to hook it up to, and maybe you could run a simpler version of it, I don't know. But anything you think would be interesting to program to do, like, I don't know, maybe program it to automatically harvest a wheat farm when it's done, or, I don't know, program it to automatically work as a rail station. I don't know, I'm just throwing out ideas here. But post in the comments anything you think would be interesting to know how to program this computer to do. And yeah, so thank you, and I'll see you in the next video.